Okay, the second part has to deal with significant figures. Whenever we collect numbers and data that we have to do calculations with, we need to make sure that the amount or that the number is representative of an accurate value. And everyone has rounded numbers before. Well, there is actually a method that is needed to be followed when rounding numbers. For instance, if I have these three numbers, 4.501, 90.2, 3.857, and if I were to add them up, we line up the decimals, add this up, 8, 5, 15, carry the 1, 8, and 9. Our answer ostensibly is 98.558. However, we want to round this number, and the number or the position that we can round it to is the position that's held in common. So it is the number with the least significant figures that determines where we're going to round this number. So actually this is 98.6, because the 10th position here is held in common by all the numbers. There's no number here and here in 90.2, and so we can't round to this 5 because we're losing information that could be contributed by these positions in this number. And so we have to ignore these two numbers and concentrate on this number. So the rules that govern how we determine significant figures are: 1, all non-zero numbers are, capitalize R, significant. All non-zero numbers. Okay, that stands to reason. Zeros after a non-zero number. Okay, zeros after a zero or multiple zeros, for instance, like for example 285,000. Okay, so that's 285,000. These zeros are not significant because zeros after a non-zero number are not significant. Okay, so that means that if I were to add up numbers and there are zeros at the end, I want to round. I don't consider rounding in these places. I go to this place. So there's actually 3 sig figs in this number, 2, 8, and 5. Alright, third rule is that numbers before and after a decimal are significant. Okay. And the fourth rule here is that zeros right after the decimal are not significant. Okay, so these seem to contradict, but if I have the example of my number up here, 4 point, let's say 051. Alright, so this is oh no, numbers. Let's read the rule correctly. Numbers before and after the decimal are significant. So we're talking about these numbers. So in this case, we have 1, 2, 3, 4 significant figures. The 0 is after the decimal, but it's followed by a number, a non-zero number. So that makes that 0 significant. But 0 is right after the decimal. For instance, 0.000485. These zeros right after the decimal point are not significant. So this only has 3 significant figures, this number, 4, 8, and 5. Okay, so we want to make sure that we represent our numbers correctly when we're collecting data. When we use numbers in our calculations, I tend to use all the numbers in the calculation, and then when I get to my answer, I round according to the number with the least significant figures. That's the best way to do that, because some of these numbers will contribute to this number, and it's only in the answer where we have to represent the correct number. Alright, the last topic is dimensional analysis, which we did a little bit of before when we talked about metric units and conversions. Dimensional analysis simply implies or means that we have to consider the units of a number, and that will help us determine what our answers would be and what our proper units should be in that answer. So for instance, if I take a number like as 13.1 grams, and again I want to go to milligrams. How many milligrams is that? 13.1 grams. We can set up a grid and say, alright, there is 1 milligram per 10 to the minus 3 grams. And our answer will be taking 10 to the minus 3 divided into 13.1 will give us 13,100 milligrams. Alright, so that is a concept behind dimensional analysis. And we'll get to do more of that as we proceed. So remember to refer back to these videos as a reminder. You'll be given problems to work as we move on through this semester. Thanks for listening.